Hello friends, welcome back. In this tutorial, we will study about minimal cover of a set of functional dependencies. A set of functional dependencies F is said to be minimal if it satisfies these three conditions. First condition is every dependency in F has a single attribute for its right hand side. Second condition is we cannot replace any dependency x implies a in F with dependency y implies a, where y is a proper subset of x and still have a set of dependencies that is equivalent to F. It means if there is a dependency x implies a in F, then we cannot replace x by any of its proper subset y, right? We cannot replace x by any of its proper subset y and still have a set of dependencies that is equivalent to F. Third condition is we cannot remove any dependency from F and still have a set of dependencies that is equivalent to F. We can think of a minimal set of dependencies as being a set of dependencies in a standard or canonical form with no redundancies. The minimal cover of a set of functional dependencies E is a minimal set of dependencies F that is equivalent to E. There can be several minimal covers for a set of functional dependencies. Now, here an algorithm is given for finding a minimal cover F for a set of functional dependencies E. Now the first step is all the dependencies of set E are passed to the set F. Now the set F contains all the dependencies of set E. Now second step is if there is a functional dependency like this, x implies a1, a2, a3, so on up to an in F, then this functional dependency will be replaced by n functional dependencies. X implies a1, comma x implies a2, comma x implies a3, so on up to x implies an. So what happens in this step? In this step, what happens if there is a functional dependency in F which is having more than one attributes at right hand side, then that functional dependency will be replaced by other functional dependencies which are having only single attribute at their right hand side. Third step. In third step, what we do, for each functional dependency x implies a in F, and for each attribute b that is an element of x, we check that if we remove that attribute from x and still we have the set of dependencies which is equivalent to F, then what we will do, we will remove that attribute b from x. Now the fourth step. In the fourth step, what we do, in fourth step we check for each remaining functional dependencies x implies a in F, that if we remove that functional dependency from F and still we have the set of dependencies which are equivalent to F, then in that case what we will do, we will remove this functional dependency x implies a from F, right? So in fourth step we will check whether we can remove any functional dependency x implies a from F or not. If we can remove and still have a set of dependencies which are equivalent to F, then we will definitely remove it.